We're going to start learning electronics from the basics, beginning with the topic of voltage. So stay with me. Alright, in this session we're going to talk about voltage, see what voltage actually is, and understand why it's one of the important topics in electronics. In the previous session, we talked about conductors and explained what materials are considered conductors. As you might remember, in their natural state, the electrons present in conductors. For example, we said that metals are generally classified as conductors. The electrons in conductors like copper move freely from one atom to another, but their movement is random and without a specific direction. They can even move around in their own positions. But in order to make these individual particles move in a single unified direction, all we essentially need to do is simply apply a significant force or a substantial pressure to them. The precise technical term for this particular type of pressure is officially called electromotive force, which is commonly abbreviated as EMF, a fundamental concept in electrical engineering. And again, for simplicity, it is represented by a capital E. But you probably know it better as voltage. If we want to give a very brief definition of voltage, we can say that voltage is nothing more than the difference in charge between two locations. Now, what does this difference in charge between two locations mean? Imagine we have a small mass made of metal whose atoms have a lot of negative charge, or in other words, we can say this piece of metal has a lot of electrons. And we have another mass that has a positive charge, meaning it has fewer electrons. So, the first group has a lot of electrons and the second group has very few electrons, and there is a voltage between these two masses. Why? Because as we said, voltage is nothing but the difference in charge between two locations. That is, I placed these two masses on the left and right sides. These two locations and the difference in charge between them mean that the left side is negatively charged and the right side is positively charged. This difference in charge between the two is what we refer to as a voltage existing between them. Now, if I were to connect these two distinct masses together, perhaps utilizing a highly conductive material, for example, a robust copper medium such as a flexible copper wire, what would then occur? In fact, what I've done here is create a circuit. You may recall that we said atoms tend to be neutral in their normal state. That is, if I have an atom with an extra electron and it has a negative charge, it tries to get rid of those electrons somehow so it can return to its neutral state. Also, if I have an atom that has lost one of its electrons and has become positively charged, it will want to quickly gain an electron to return to its neutral state. Now here I have two masses that are not neutral. One of them inherently possesses a negative electrical charge and the other distinctly holds a positive electrical charge. To electrically neutralize these two distinct entities, I carefully place a conductive copper wire directly between them, and this action consequently causes an observable electric current to be generated within the circuit. How is an electric current generated? Like this. When I place a copper wire between these two masses, the excess electrons, we said that this mass is made of metal and metals are conductors, so electrons can move easily. These electrons are moving through this copper, and I'm just schematically indicating that, for example, these are electrons. As they move in this way, the electrons travel from this negatively charged mass into this positively charged mass. Why? Because this positive mass contains atoms that have empty spaces where they can accept electrons. So the extra electrons that are here in the left mass don't have a specific place. They start looking for a new place. They move from the negative side to the positive side. These electrons start to flow. They move. You see, when they move, a current is created, that is, an electric current is generated. This continuous movement persists until all the abundant extra electrons from the left side have completely transferred and moved to the right side, at which point both masses become electrically neutral and balanced, and that is precisely when the electric current definitively stops. Now, there are a few crucial and important points about voltage here that I will meticulously mention and elaborate upon so that we can gain a much better and more comprehensive understanding of the fundamental concept of voltage. We have previously stated that whenever there exists a significant charge difference between two distinct places or locations, if those particular places are indeed connected by a suitable conducting medium, there is a very strong possibility that an electric current will inevitably flow between the two aforementioned places, and, as is commonly stated, a continuous and sustained electric current will be effectively established and maintained. That's precisely why we have a very important term here, the fundamental term potential, which is quite often utilized to accurately describe electrical voltage, a crucial concept in physics. So in the future, when we are talking about electrical circuits or discussing problems and we mention the term electrical potential, we mean the same thing as voltage. This charge difference that exists, and with the copper wire we place between the two conductors, which causes this charge difference to decrease due to the movement of electrons. We call this potential. Without voltage, there is no current. As we said, voltage is the difference in charge between 2 points. So if there is no charge difference between 2 points, there will be no current. Therefore, voltage creates the potential for current. Now, if we compare the electric current that flows to the flow of water through a faucet hose, we can think of voltage as the water pressure present in the faucet. It is this water pressure that causes the water to flow through the hose. For example, we notice that when we turn on the faucet, very little water comes out. We say the water has no pressure, but when the water is under high pressure, a much stronger flow is created. We can use this example to say that voltage is like the pressure we consider, and that's why we've used the analogy of water and a hose here. Because in the previous session we talked about electric current, we said that the scientists of that time compared the movement of electrons to the movement or flow of water, and that's why they called it electric current. Now, voltage, like electric current, is measured with a unit that we call the volt, which is usually represented by the abbreviation V. Or if we consider a flashlight battery, for example, its voltage is 1.5 volts. A car battery also provides us with 12 volts. Now, for example, to see what these numbers mean. How is it that we say there is 220 volts, for example? There is 1.5 volts. How can we measure these? There is a device called a voltmeter that has 2 wires, which we can connect to different points in a circuit so that we can see what the voltage is like between those 2 points. That is, consider these 2 probes here as those 2 positive and negative terminals. We connect one to one of the terminals and the other to the other terminal. And this voltage that exists, meaning the force that causes these electrons to move, is what we can measure. Using this, we can see how much voltage exists between these 2 points. The typical shape of a voltmeter also looks like this. Of course, there are different types of voltmeters, but here you see one example. But let me mention that the device shown here is a multimeter, which allows us to measure other things as well. However, this multimeter is capable of measuring voltage, current, and other things, which we will fully explain in its own session about the multimeter. I just wanted to point out that there are devices specifically designed to measure only voltage, and there is also a device called a multimeter which can measure other things as well, including voltage. Now, one issue that comes up here is whether the voltage is positive or negative. I can tell you that voltage can be either positive or negative, and this depends on the point relative to which you are measuring the voltage. What does that mean? So what does that actually mean, for example? Which point should I measure the voltage relative to? For example, consider this battery or those 2 masses I showed you earlier. Just keep that in mind. So a battery has a positive terminal and a negative terminal. Now, if I take the positive side, meaning here as the reference or the origin for measuring voltage, let's measure the voltage from here relative to the negative terminal. So in this case with the battery, we say that the voltage at the positive terminal relative to the negative terminal is 1.5 volts, or in other words, positive 1.5. That means from this particular perspective, I can confidently consider this specific point as a positive 1.5 volts right here. However, if I meticulously take the reference point as the negative side of the circuit, I can then precisely state that the electrical voltage at the negative terminal, when measured relative to the positive terminal, is indeed a value of -1.5 volts. This fundamental concept is crucial for understanding circuit behavior and potential differences. So if I take this as the so-called starting point, if I take the positive terminal as the 0 point, then relative to the negative terminal, it has a positive 1.5 volts. But if, for example, I take the reference point or my origin point for the movement of electrons or for measuring the voltage, then I would say that the negative terminal has a voltage of -1.5 volts relative to the positive terminal. Now, if I want to give you a precise definition of a volt, I should say that you also need to understand some other concepts like power so that we can fully grasp the concept of a volt and it becomes clear for you. I'll definitely explain what power is in future sessions, and then you'll be able to fully understand what we mean by a volt and how we actually perform these measurements. Now, the final point here is that we said that when we have a positive and a negative mass and electrons move from the negative side to the positive side, this movement of electrons from negative to positive continues until the two masses become electrically neutral. And we also mentioned that these two masses are made of metal. If we go back to the topic of electric current, we said that in metals, electrons move randomly and are not fixed in a specific position. And even if it is electrically neutral, electrons are still moving and their movement does not stop. But if I apply a force, which we called what? We call this force voltage. If I apply this to that mass, it causes the electrons to become oriented, so they no longer move randomly, and instead the electrons move in a specific direction that I intend. So when there is no voltage to apply pressure or force, the electrons once again move randomly. As we can see in this diagram, this is a simple circuit. I have placed, let's say, two metal pieces here, connected them to a battery here, and created a circuit here. Pay attention to this part. When the circuit is closed here, the electrons are moving in this direction. Look at both the top and the bottom. They're moving in this direction. But when the circuit is open, you see the electrons are just moving in place. What does that mean? It means that this battery here applies a force to my electrons, which causes movement. In the previous session, we talked about the direction of electron movement or electric current, and we said that there is the actual direction of electron movement and there is a conventional direction. The conventional direction is defined as movement from positive to negative. That's the one we use in problems. But normally and intuitively, or in reality, if we want to say it, electrons move from the negative side to the positive side. As you can see here, when I place this battery and the circuit is closed, their direction is this way. In other words, the actual movement of the electrons is from negative to positive. Why is that? Because here this battery has a negative terminal and a positive terminal. But conventionally, and I'll just mention this for now, let's keep this in mind and not get into it until we reach the relevant topic, where we'll deal with it more in our problems. There, the conventional direction of movement is considered from positive to negative. I'll explain it to you fully there, so for now, just keep these definitions in mind. So in conclusion, we can say that voltage is the difference in charge between 2 points and the force we apply to those electrons, which causes them to move in a certain direction, creates electric current for us. So this is a brief and summarized definition of voltage. Now, how it is measured, what voltages are used for in a circuit, how we can use them, and how to have a precise understanding of them. I'll explain more about these topics in future sessions. And for now, I'll wrap up this discussion here, so that in future sessions, we can become more familiar with this topic and other subjects. If you have any questions in this regard, I'd appreciate it if you ask them through the contact methods provided, and I hope this session has been useful for you. So until the next session, goodbye.